Okay, let's continue to the next 3-2. I will share with you the PowerPoint 3.2. Okay, hopefully you can see it. Introduction to signal generator, architecture of signal generator. So this is a signal generator. You can see this instrument in the lab, but unfortunately you are not here in UMP, so you can just see from the photo. So device that generates signal of various frequency and amplitude, type of signal generator, audio, radio, microwave, function generator. Oh, microwave. Very high frequency, 1 megahertz to 100 gigahertz. So this is the example of function generator. That is the brand Textronics PK Precision. So what is the function? What is a function generator? A function generator is a device that can produce various patterns of voltage at a variety of frequency and amplitude. It is used to test the response of circuits to common input signals. The electrical leads from the device are attached to the ground and signal input terminal of the device under test. Most function generators allow the user to choose the shape of the output from a small number of options. So you can generate a square wave, sine wave, triangle wave for a specific application. The amplitude control on a function generator varies the voltage difference between the high and low voltage of the output signal. So the current DC offset control on a function generator varies the average voltage of signal relative to the ground. Frequency control the rate at which output signal oscillates, so you can control the frequency. One set of control chooses the broad frequency range and the other select the precise frequency range. How to use it? Okay, you can go to the lab and explore by yourself. After powering on the function generator, the output signal needs to be configured to the desired shape. Typically, this means connecting the signal and ground leads to an oscilloscope to check the control. When you generate using a function generator, then you connect to the oscilloscope to check it, whether you get all the values, all the parameters of the signal or not. Adjust the function generator until the output signal is correct. Then attach the signal on and ground leads from the function generator to the input and ground of the device under test. For some application, the negative leads of the function generator should attach to a negative input, but usually attaching to the ground is sufficient. So this is the architecture of signal generator. There are various forms of signal generators, and which you choose depends what you want to do it. Various waveforms generated by several different kinds of instruments, which range in complexity. Simple fixed frequency sine wave oscillator, highly sophisticated instrument for testing complex instrument. Type of signal generator working on high-end audio equipment. You will want an audio oscillator, a low distortion sine wave oscillator that can be used as a signal source for checking total harmonic distortion. So these signal generators operate in the audio range, usually going from around 20 Hz to over 20 kHz. If you are working on communication equipment, then you need an RF signal generator. These have a frequency output 50 kHz or lower, 250, 500, 1 gigahertz or more depending on the model. All-rounder signal generator is the function generator which outputs a sine wave, triangle wave, or square wave. Most have a frequency range around 1 Hz or less to over 1 megahertz. Pulse generator produce a rectangular output waveform. The frequency range is from a fraction of a hertz to several. Flat frequency generators provide an RF sine wave output that can be varied smoothly and continuously over an entire frequency band. The signal generator consists of the following major subsystems: synchronization, digital gain, digital to analog, interpolation, clocking, trigger and event. So this is the block diagram of the signal generator from National Instrument. So you have PCI bridge, PSI timing and triggering, DAC ASIC, analog filter, clocking engine, so on and so forth. Synchronization and memory cores, SMC, in the signal generator. Modern signal generator implement deep on-board memory to store large waveform. PCI or PXI-based instruments are able to use this memory effectively. Signal generators use on-board memory to store both waveforms and sequence instruction. The instruction for a complicated sequence can occupy a significant block in memory. Next is a digital gain. Because signal generators are designed to generate signals over a wide range of voltage level, both analog gain amplifiers and digital gain processing are used to maximize the amplitude, accuracy, and the flexibility of the signal generator. DAC. So this DAC is to convert digital to analog converter because you want to generate a signal. Interpolation and filtering. DAC are able to approximate only truly ideal signal. In fact, because the step up of a DAC result in high frequency images, modern signal generators implement both analog and digital filters to provide the best approximation of an ideal analog signal. First, a digital finite impulse response filter interpolates the signal to increase the effective sampling rate. By increasing the effective sampling rate, the nearest spectral images center around the new effective sampling rate. Next is trigger and event. For synchronization with other instruments, the SMC architecture offers features such as marker event and data marker. So with this type of output trigger, the state of the trigger is embedded into the actual form. So that is the chapter 3.2. You learn about the signal generator. It is the theoretical of the function generator. So the function generator has the features and control. Then how to use a function generator, architecture of signal generator. So and also a lot of the architecture of the signal generator. So you can get this material PowerPoint as this is more to the theoretical, so you can read it by yourself. So that's all for the chapter 3-2. See you in the chapter 3-3. Thank you very much.